Hello, everyone. Welcome to Snowpark Container Services session. My name is Muzz Imam. I'm the product manager for Snowpark Container Services, and with me, I have the honor to have from NVIDIA, Nick. Nick, you want to introduce yourself?
Hello, happy to be here. My name is Nick Becker, help do product and engineering for NVIDIA Data Science.
Cool. Awesome. Let's get started. So the slide is showing the wrong name there, by the way. That's not Miles. We have it from the other demo. But let's talk about what is Snowpark Container Services. So you saw some really awesome demos this morning in the keynote. I hope you loved it. The product and the platform behind it is Snowpark Container Services. And we're going to quickly walk you through this. Now, this is going to be quick because it's a theater session. We have a full session tomorrow as well, if you want to attend and go into more details. Snowpark Container Services is our container platform, which is fully managed and built for data cloud. What it means that now you can start bringing your own containers and containerized workloads and run them right next to your data layer. And not only that, you get to tell us what kind of hardware you want to run it on. So for example, you can run it on CPU or NVIDIA GPUs. And the great part is we provision those GPUs for you. So you don't have to wait in line for those very hard to get GPUs these days. We'll do that for you. All you need to do is bring your containers. Now, it means that you can start running any kind of workloads that you want. For example, C++, R, all those workloads or libraries or frameworks that you have been asking us to support now get supported because it's your container. You build it. Whatever you want to bring, you can bring. And then this comes with the whole security and governance and ease of use of Snowflake. And that was the hardest part building this, right? Tight integration with the warehouse. You don't have to go outside. Your data doesn't need to leave Snowflake. And then you get all that flexibility, but you do not get that complexity. You don't have to set up your own image registry and observability stack and all that. It all comes out of the box. And that's the power that Snowflake is bringing you. And one more thing. You actually now get to, as a developer, package it up, and you will be able to start distributing and monetizing it using Marketplace. And as a consumer, you saw so many partners like NVIDIA and others. There are so many here out there on the booths already have their apps. So as a customer, you can just install that app and run it securely inside your Snowflake account. So if we move to the next slide, as you can imagine, this is a very powerful platform, and we can support a lot of workloads. But our focus initially is going to be on these 4 types of workloads, starting with ML workloads, which a lot of you wanted to train machine learning training jobs using GPU, then deploy it as an inference endpoint. Nick is going to walk us through how to do all of that with NVIDIA libraries and NVIDIA acceleration. And then, of course, LLMs. If you want to deploy an LLM today, you have to learn the complexity of Kubernetes. You have to set up a lot of things to get going. We have made it really easy to procure those GPUs, to procure libraries. Everything is available to you. You can bring any open source LLM or the ones we are providing and we announced earlier today. And then, of course, you can bring the full stack web applications you saw with the UI, with the backend, with the front end. So if we move to the next one quickly, the main value add we're doing here is the ease of use, governance, and security. So as you can see, from a development to deployment lifecycle, it's as easy as 1, 2, 3. 1, you need a container. You can create your own using something like Docker. And then you need a configuration file. Number 2, you need to create a compute pool using SQL or CLI or Python, whatever you love. And then you are gonna tell us how to use those containers as a job, as a service, or as a service function. Now, it's important to get through this, and I'll hand it off to Nick. Service is that long-running service with an ingress endpoint. Think of it web API, right? That's always up and running. You can have that running as a container. That's services. Jobs is, as the name says, is for a specific task. It runs it, and then it kills itself. And then the last one is service function. You can prompt it like an LLM function, and you can start getting answers, but that function is powered by a container. And all of that with ingress, full secure ingress. With egress, you can go outside. And with all those observability and all that goodness. To see all of that in action, I'm going to hand it off to Nick. Nick?
Thanks, Muzz. And as a reminder, this is just a brief 20-minute session. Everything we're covering today, you can see again in a longer format tomorrow in the additional What's New in Snowpark container session. So before we go forward, I want to take about 30 seconds just to level set. Some folks here might be very familiar with NVIDIA. Some people might be only partially familiar. What is NVIDIA? NVIDIA is the accelerated computing company. That means NVIDIA builds hardware, software that really deeply runs low level on that hardware, core libraries to help people take advantage of that accelerated hardware, and application frameworks that allow you and your customers to bring accelerated computing into applications as wide as chatbots, to physics, to computational fluid dynamics, forecasting, and recommendation systems. NVIDIA capabilities are now possible to use through Snowpark containers. I'm very excited to go through a brief 10 to 12 minute demo today that...
Sorry,
yep.
your voice is a little bit lower.
Oh.
He's going to fix it.
Yeah, thanks so much.
Yeah. Sorry about that.
No problem. Very excited to go through a brief 10 to 12 minute demo that explores exactly how you can do this and show what you can now do. So I'm going to make this a little bit larger, just so folks can see better. This is the Snowflake user interface. Folks here are likely very familiar with it. What we're going to do is go between this UI and a Jupyter notebook. Jupyter Notebooks and Jupyter Lab are fantastic tools that let us build out workflows, doing data analytics, processing data in a very friendly format. And what we're going to do is spin up a Snowpark container service to run this Jupyter Notebook. We can do this through a series of very straightforward DDL commands in the Snowflake UI. The first thing I'm going to do is create an image repository. Snowpark Container Services, as the name implies, relies on containers. Snowflake has a brand new image repository that we can push our containers to. I've already done that for the sake of time. But what I'm essentially going to do now is use a container that I've already pushed to spin up a service that I'm going to call Snowpark Container Services. And Snowpark Container Services lets me configure this with a few different key parameters. The first is the number of nodes as a minimum, as in, I need at least this many nodes. I only need one. But I can also scale up to more nodes depending on my application. So it allows me to go minimum and maximum. I can also choose the instance family. In this case, I'm just choosing one of the very cheap, small CPU instances, but I could just as easily choose a high memory instance, compute optimized, GPU instance, whatever I like, and whether or not this should be auto-resumed. And so when I actually, well, it looks like I already created this, but now that this is running, I can do commands like show compute pools to see that it's running. I could kick this off 2 minutes ago, so it's already running, but could have done this just now. What this lets me do now on this compute pool is actually create my notebook service. The compute pool is the underlying instance that this service is going to run on. And so we picked a standard 2 instance with 1 node, and we called our pool Snowpark Container Services. That means to create our notebook service, we're going to essentially just refer to this compute pool name. But you might notice that we're also going to refer to a YAML file. Like many other similar setups, we get to configure exactly what this service is going to do. How do we tell it to spin up a Jupyter notebook? It's not going to know automatically. So for that, I'm going to switch to Visual Studio Code really quick. And we can see that, I'll make this a little bit larger, that I can create a manifest file. This manifest file determines what my service will do. In this case, I'm only doing something very straightforward. I am choosing a container. In this case, I'm grabbing a container from the NVIDIA repository. I am mounting a Snowflake stage. Snowpark Containers allows you to mount a stage for persistent storage of artifacts, data, assets, and more. And I can give that stage a path and a name in this container. And then, of course, because it's a Jupyter notebook, I need to expose the right port. I'm going to expose port 8888, which is the default for Jupyter notebooks. But most importantly, I'm going to call this public equals true command. This command is not by default true, but it means that this service is going to be accessible to the public if they can authenticate through the Snowflake secure infrastructure. It's not like anyone can access it, but I can toggle services to be publicly accessible through the standard Snowflake security authentication, which is really powerful. So with this, I can go actually create my service, which I'll do right now. Go back to full screen. And so when I create this service, it is essentially going to take a second or two to spin up. And once it does, I can use other Snowpark container system calls to check the status. In this case, we can see that it's pending. It's still going up. If I check it again, 2 seconds later, it's ready. This service is running. And what I can actually do now is go look at the service information, the metadata, and I can see that I have the name, the specification that I created in that manifest file, and most importantly, I have the public endpoint, this on the right here, and the actual address is part of this. So I'm going to take this address and go to it. This is now live, and so I can now log in through the standard authentication and start doing my workflow. And so for the next 7 or so minutes, we're going to go through an example workflow that we are going to access through the stage that we mounted. This container doesn't have the workflow in it. It's accessing it through the stage that Snowflake allows to be used from inside Snowpark Container Services. And so I'm going to go through a workflow showing how you can do a machine learning fine-tuning job. So you can take a deep learning model off the shelf, fine-tune it on your business's data, and persist that model and then serve it all within this secure infrastructure. In this case, we're going to imagine that we are a guitar selling, piano selling, music services and music products e-commerce store. So we're selling guitars, pianos, everything in between. And so as a business, we can connect to Snowpark containers, our data teams, our data science teams, and we can immediately access the standard Snowflake and Snowpark environment in our container. There's a token that is provided as part of this container infrastructure that allows me to just directly connect to my Snowpark infrastructure. And so in this infrastructure, I have access to reviews that customers have left on my store website. I have millions of reviews. We're a very successful music product store. But we can see just the first few here that someone really liked an electric guitar, 5 stars. Someone thought a piano was just okay. Maybe the keys were a bit stiff. There's a lot of insight here that we want to be able to have our data teams and our data science teams take advantage of to help drive the business forward. One way to do that is to take advantage of all the AI and ML capabilities that are now available through Snowpark Container Services. So we can take these millions of reviews and we can create vectors of numbers transforming the sentences in our reviews into meaningful numeric representations using neural networks so that we can do things like build recommendation systems, do topic modeling, do similarity search, and everything in between. So to do that, the first thing we get to do is maybe just pull a model off the shelf. This is what pretty much every data scientist in the world is going to do before they do anything else. I'm grabbing this model from Hugging Face. It's a transformer model. Pretty straightforward. And we want to test that model. So I'll test it by looking at a few sample sentences. The first one being, my Martin 016 NY is a beautiful piece of craftsmanship. You might not know what that is, but as a store owner, I know that that's a guitar. So I know that that sentence and the third sentence, my guitar is a beautiful piece of craftsmanship, should probably be represented pretty similarly by our model, because at some level, it's basically the same sentence. So we can actually test that by using our off-the-shelf model and comparing this with a cosine similarity score. We can see in this third cell down on the left that these two sentences are actually not that similar. Between 0 and 1, it's about a 0.5. That's not what we want. We want our business's specific information, the jargon, the key content in our data to be understood by the model. So we can fine-tune. Snowpark Containers infrastructure allows us to spin up through infrastructure as code the necessary pools and resources that we can do to actually make this happen efficiently. So the first thing I can do is check to see if I have an NVIDIA accelerated instance available. I do. We spun this up a few minutes ago. You can see that it's active. And again, this is infrastructure as code, so this can all be orchestrated. And with that, I can execute a job with the execute service statement to train and fine-tune this model. And again, I configure it with a manifest and give it the compute pool. So I'm going to run this job. And as we do that, I'm going to quickly shift to Visual Studio Code. Visual Studio Code again. And we can see that the job manifest is very similar. I am configuring with a container, with a stage. This time I'm running a script, though. I'm passing in a train.py script. And this script is also available. I've put this script together. It's actually very much the same as the notebook, where I'm just authenticating and using a few example sentences for fine-tuning. In the real world, we would use much, much more data to fine-tune than 7 or 8. But by fine-tuning a model with expert-defined labels, I can then create a new model in the Snowpark infrastructure that understands my data. And we can go back to this. We can see that this job has completed. But I'm going to run it actually again, shifting to our GPU resources tab. And we can see that as I kick this job off, in a moment, we are going to see additional resourcing spike up in this user interface to show that not only did our job execute, it is executing efficiently, as we're getting excellent utilization, upwards of 80% on the GPU infrastructure. When it's done, we can go right back to our other setup. We can grab the results, and we can check our logs. And so we can see through all of the standard logging, observability, and security to come to expect with Snowflake and Snowpark is available in the container services as well. This is a very long log showing every iteration because I am very silly. And we can see that everything gets logged, and it's all captured by Snowflake. Most importantly, again, as infrastructure as code, we have access to spin up and spin down these resources. I don't want to leave this job running, the compute pool running. That costs money. So I can suspend this, no longer get charged, confirm that this is in a stopping state, and then verify that my fine-tuned model works by grabbing the model from the stage where we assigned it to go in our script. And we can see that by fine-tuning just on a small set of data, we can push up the score from 0.5 to about 0.8. This is great. This is a huge step forward, but we can do so much more. In fact, we can take this model and deploy it. We want to create these vector embeddings. Well, these vector embeddings are designed to be used, but we have to do it on millions of records. Doing that efficiently requires inference, it requires efficient multi-GPU resourcing, and everything in between. So I'll go a little bit quick here, because we only have about 1 more minute. But what we can do, again, is resume that instance we just stopped. Infrastructure as code, it's perfect. We can confirm that it's still running, and I can create a new service. In this case, using NVIDIA's open source inference server called Triton that allows efficient model serving of any type of model, from deep learning to machine learning to black box models on any type of infrastructure, whether CPUs or GPUs. And again, I configure it with another manifest file. I'll skip the details of this, but suffice to say it supports multi-container pods in Snowpark Container Services, and we take advantage of that here. With this service running, I have to run that. With this service running, I can confirm that it is pending and then ready. I think I added an extra line. We can see that it's ready. And I can now create a services function that's going to hit that service endpoint. This is an inference server. I'm going to hit this endpoint in my services function. And it's all secure, because it's by default, there is no public access. We saw that public equals true command for the notebook. That's not happening here. And with that, I can use this function in a SQL statement, again confirming that the GPU is active, sending batches of row size 1,000. And when it finishes, we can go back to our UI and take full advantage of the fact that we now have access to accelerated inference and machine learning and deep learning model deployment in SQL for our entire organization to take advantage of. We can see that at the end of this, we have a new column of our vector embeddings. So with that, I'll just conclude by saying we're so excited to be working with the entire Snowflake team, the Snowpark team. All of the work that we've done here is available through the NVIDIA AI Enterprise software stack that you can purchase for security, support, API stability, and more. It supports more than 4,000 packages in the AI development stack. It's very important that when we go to production, these are secure. AI Enterprise allows you to give that production-grade confidence to your applications. Muzz, I'll pass it back to you.
All right. Are we showing this?
There we go.
All right. Cool.
All the way?
Yeah.
Yeah, you just,
All right, that was cool. We ran out of time. We have a lot more to cover. As I said, there is a more detailed session tomorrow. That was a great demo. By the way, we're just getting started. Our whole goal is to bring this power of containers with the ease of use and integration. There's a lot more to come. So find us after the session, and then we'll answer any of your questions. Thank you.